give a small introduction about our guest of the day. Ma'am, please.
Thank you, Sovana. Professional technologist Parthiban M. Vartharaju is a lecturer and program coordinator for Management Information Systems Cluster in the Faculty of Business and Management at Ames University, where he's been working since 2011. Mr. Parthiban has received his Bachelor of Computer Science in Software Engineering from the University of Malaya in 2004 and his Master's degree in Information Technology from the University Utara, Malaysia in 2016. Currently, he is pursuing his PhD studies at the Advanced Medical and Dental Institute, Malaysia, in the field of computational biology. He is a registered professional technologist with the Malaysia Board of Technologies from the year 2020. His research interests span both software engineering and artificial intelligence. Much of his work has been on improving the understanding, design, and performance of the computer systems, mainly through the software requirement analysis and modeling, software architecture and design, software testing, software process, and quality assurance and performance evaluation. We are indeed very happy to have you amidst us, sir. Now I hand over the session to you.
Thank you, madam.
Thank you, sir.
I feel so blessed and honored to be part of this session, FTP program conducted by HICAS. So I need to convey my sincere thank you to Dr. Sudagar and the team members for giving me this wonderful opportunity to share my knowledge with all of us here today. So without further ado, I would like to share my screen about the presentation. Okay, so let me share my screen. Okay, today I'm going to share about the bioinformatics as an emerging field of data science. So before I would like to share some information about the bioinformatics and data science, I would like to have this poll. So I will be sharing the link in the chat box. Okay, so maybe I will copy the link for you. Maybe I want you to go to this link and then click the poll, answer the question, okay, in the poll. So I'll be sharing the link here in the messages chat box. So you can click to that chat box. So it's about okay, so it's about the term and common tasks of bioinformatics. Okay, so you can share your choice here, whether you know about the term and common tasks involved in bioinformatics. So later I will share with you the result, okay, about the poll here. So now we go back to the slide again. Okay, you can click to the link I've attached here in the chat box. Okay, what is bioinformatics? So today is our title is about bioinformatics emerging field in data science. Right. So bioinformatics, I think you have experience, you heard about the bioinformatics before. So what was once seemed impossible and formidable is now possible by a field called bioinformatics. So bioinformatics is a field that applies statistics and information theory to make sense of biological data. Okay, we have a lot of data, especially in the biology environment field. So bioinformatics helps us to reduce the molecular basis of how disease arises. For example, how mutated genes work. Okay, for example, identify which gene is responsible for the disease, compare the gene frequency of two cohorts. For example, disease cohort versus non-disease cohort. So you have a lot of data that populated, okay, through research and through the findings, experiments. So that's how bioinformatics, it's one of the field mainly to discover, okay, to discover the hypothesis, okay. Bioinformatics lies at the interface of biology and computer science. Okay, it's mainly involved about the statistical information, okay, mathematics formulas, and more about the deep learning, okay, algorithms. So it is an area where computers are used to make sense of big biological data. Okay, so bioinformatics is especially important in the age of post-genome, okay, where various omics are born. Okay, those days in 2000, we actually have this post-genome where there is a research data populated from biology environment. So slowly it actually created, substitute or created more other data, okay, genome or proteome, okay, metabolome, microbiome, metagenome, interactome. So different molecular, okay, data generated through these bioinformatics studies recently. So generally, there are common tasks, okay, in the bioinformatics. So in bioinformatics, we have the common task to analyze the data, okay, to analyze. So there are 4 important common tasks in bioinformatics. First is about searching, okay, searching. We can use any public databases for information on genes, proteins, RNA pathways, okay. So I'm actually relate to the biology environment, okay. Slowly I will move on to the data science later on. So now I'm just giving you the understanding overview about bioinformatics, mainly is about biology, right? So we have public databases for information on genes, proteins, okay, RNA pathways. Even in your own research in other environment, you will do the searching, right? Searching with the public data sets, public databases, which is available out there. Okay, once you search, and then you will compare, you will study, you will do the literature studies, compare the hypotheses in the different types of experiments. Okay, so the sequence, alignment to discern similarity or differences amongst various genes. So I'm related to the biology, various genes, proteins, RNA. So once you compare, you will have the important findings, which is again another big group of data. So after you search, you compare the alignment of the similarity or differences among the various genes. You need to form a model. Okay, why we need the model? So this model will help us to understand, okay, to know better about the data that we populated from the experiments that we conducted. So build structural model of protein structure, okay, or we call build predictive models using retrospective data. Okay, so I'm relate again to the biology again for this topic because it's involved bioinformatics. So once you create the model, okay, structural model of protein structure, you will do the analysis. Okay, so for perform the analysis, you need to have programs, okay, applications, algorithms. Okay, once you create a model, you will integrate and
Okay,
curate,
sorry to interrupt.
combine heterogeneous data sources. Okay,
Sorry.
you will combine the heterogeneous data sources to avoid any redundancy. Okay,
Parthiban
so
sir, excuse
yeah,
me. We
sorry.
have one of our participants wants to say you something. Ma'am is?
Ma'am, like, we couldn't see the presentation to the screen. Just now, let's scrolling.
Okay.
Sorry?
Sir,
Slideshow is not open.
We are seeing buses only, sir. Interrupt you. Sir.
Was it?
so we are unable to see presentation.
Oh, you can hear my...
Yes, sir. Yes, sir. You're audible, sir.
Oh, okay, sorry.
Excuse me, ma'am. It is actually visible, but not in a slideshow mode.
Slideshow.
So kindly.
Oh, okay, sorry. Is it visible now?
It's visible, sir, but like it's not in slideshow mode.
Slideshow mode.
Yes, sir. Now it's perfect.
Okay. I'm so sorry. I'm so sorry.
Not a problem, sir.
So I think I already explained about the bioinformatics. Okay. So the area of bioinformatics, and then the example I'm sharing with you just now, and then we're talking about the common tasks involved in bioinformatics. So finally, the fourth main task in bioinformatics is to integrate and curate. So what is here is combine heterogeneous data sources, okay, to find out whether there is a redundancy in the data, big data that we populated through the experiments, okay, in the biology environment, computational environment. And after, these are the detail of tasks that involve in the bioinformatics. We search, we compare, okay, we create a model, and then we integrate. So search, as I explained just now, about public databases for information on genes, proteins, okay, RNA pathways. So these are the related to biology environment. Okay, then I will move on to the data science later. So once you completed the search environment, okay, and then you will compare the sequence alignment, whether there is a similarities or any differences amongst various genes, proteins. Okay, then you will combine, okay, to build structural model of protein structure, example. So to build a predictive model using retrospective data. So why we create this? To justify the research, okay, to justify what we actually gathered, the data that we gathered. Once we done the research literature, we need to compile it, and we need to form as a model, okay, to justify our findings. And finally, to after you study the data, okay, definitely there will be a redundancy. So we need to integrate. We need to learning, deep learning, and find out what are the hypothesis, okay, the details on the final output of the research. And yeah, here they have mentioned that now we move on about data scientists. Okay, I just now have explained to you about the bioinformatics, mainly bioinformatics, the field of biology and computer science. And within this biology and computer science, you will be involved with the algorithm creation, deep learning, machine learning, okay, which is involved in biology environment. Okay, so here, if you can see, data scientist is termed as the sexiest job, or we call hottest job of the 21st century by Thomas Davenport and DJ Patel in their article published in the Harvard Business Review. Okay, you can refer to the source here. So he have actually mentioned, okay, write up the article in 2012. Okay, so data scientist is a future job, okay, for all of us. So what is data science? What is data science? Data science is a process of learning about the world around us by analyzing data. Okay? Or we can say simply put, data science allow us to make sense of data. So that means whatever data that we collect or any data that available in the public resources, so we will collect as a researcher, as a lecturer, as a student. Let's say I've involved in the project. I will collect a lot of data to analyze, to study on the literature, to do the method, okay, to analyze the data. So data science allows us to make sense of data. So whatever data that we collected, whether the data is really help us to give any idea, opinion, okay, for our research, okay, to further our research, to expand our research. So data, so the process involved between data and insights, okay, we call data science process. So what are the process involved when we transform the data into information? So to populate as an information, you need to go through with a lot of process. Okay, so what can data science do? Exploration. Okay, we need to explore. So why we need to explore? To discover hidden patterns from the data. Okay, and the next thing is about the descriptive statistics and data visualization. So what we actually can learn from the data. So what are the information can provided by the data, and how we want to visualize the data. Okay, visualize in the form of charts, bar charts, pie charts, any kind of visualization that help us to in our research. And next is inference. Apply statistics to draw conclusions from the data. So this is the second part in the data science. Okay, can help us to analyze the data. And the third one is the prediction. So once you collect the data, you analyze the data, you come up with a statistic, data visualization, and then what you will do? You will apply machine learning to make data-driven guesses on new data. So that means from what you have collected, from all the data, from the public resources, the data that you collected, you will form a new data, okay, by using the machine learning algorithms. Okay, so to make data driven on new data. So next is we look at the data science life cycle. So previously I've explained to you about what data science can do, right? So these are the process involved in the data science. If you look at the system development, so you can relate to the system development life cycle, SDLC. The same concept will be applicable for the data science life cycle. As the beginning part of the data science, you will do the collection. Okay, you collect a lot of data, and then you need to clean up what is important, what is not important, what you need, what you don't need, okay, for your research. And then you will proceed with the exploratory data analysis. For the analysis, you will use a different type of method to analyze your data. Okay. And once you analyze the data, you will create a model. It can be a physical model or logical model to support your justification, to solve your problem. Okay. So at the end of the life cycle, you will create a model to deploy to the to solve the problem. Okay, the final model deployment. So here you can see different important roles will take part of this each phases in the data science life cycle. For example, data engineers. Okay, they mainly will looking at the collection, cleaning of the data, big data. And then the second role will be data analysts. They will be more on the analysis part, analyze the data. okay, analyze and do a lot of searching, okay, study on the data to explore what they can get from the data they have collected. And then machine learning engineers, okay, so they will apply the data that they collected, they analyze, they will put into the programming, machine learning. Okay, it can be in the form of coding, programming, algorithm. Okay, so the whole process, at the end of the day, the data science life cycle is actually to lead us to a data science evolvement. Okay, you form a new role, okay, by having all the data engineers, data analysts, machine learning engineers, you form a new role as a data scientist. So these are the whole thing about the data scientist in the data science environment. Okay, what are the skill sets of a data scientist? Okay, out there, people are, a lot of companies are asking for data scientists. We want to expand our business. We want to explore the data that we have. So they are looking more to the data scientists. Nowadays, you go to any company throughout the world, they are looking for the data professionals. Okay, data analysts. Okay, they do that data analytics. So what are the skill sets that you need to become a data scientist? So what does it take to become a data scientist? You can see here there is chart here. Okay, it's developed by data professor Chanin, Associate Professor Chanin Nanta Senamat. So he's came up with this idea. Okay, it's a data science landscape. So that means data science not only involved with programming, not only about biology, not only about the mathematics. It's about engineering, data pre-processing, statistics, programming, mathematics, data visualization, machine learning, soft skills. So it's involved many other skill sets to become a data scientist. Okay, if you look at the mathematics, so you will perform a different type of, you will be using a different type of algorithms, okay, to analyze the data. Okay, you can use linear algebra, you can use the probability theory, calculus, any method that you can use from mathematics, and you apply in the programming. You can use any programming language, from R, for example, programming Python. And then after you create, you need to visualize. So you can use the relationship. You form a relationship, okay, between the data that you collected and you analyze. Okay, so this picture will give us a rough idea. Okay, what are the skill sets need to be adopted by a professional to become a data scientist, for example. Okay, so, and we look at the machine learning. So machine learning, you have a supervised learning and unsupervised learning. What is that? Supervised, we guide them. Okay, we create something with guidance. Unsupervised, we learn something with limited resources. We try, error, then we get the output. You try again, you get another output. So it's about the unsupervised learning. So overall, so these are the main skill sets, okay, to have to become a data scientist. And example, okay, in data science, what are the use cases use data science? Okay, for example, if you can see here, there are some of the examples I've shared. Okay, not only limited to these examples, use cases. Actually, there are a lot of other use cases. I'm just sharing some of the examples so that you can have an idea about the data science. So, for example, computers, IBM Deep Blue, okay, had defeated human in Jeopardy and chess. Okay, Jeopardy and chess environment. So that means you can play games, okay, online games with the machine. So not like those days. Okay, you design the concept and then you give it to the human being to play the games. Now computers, you compete with the machine. So that means as a human, we will have limitations. Okay, so and we will not be a perfectionist. Okay, so but we can use our intelligence, okay, to create a machine, okay, by using algorithms. Okay? For example, Google released a self-driving car developed by human, but with the artificial intelligence technology. Okay, this is another use cases of data science. And let's look at NASA. Okay, uses computers to simulate space missions, for example. Okay, so it's involved about machine learning, artificial intelligence. Okay? So computers are being used to design aircrafts and cars. Okay? Supermarkets and shopping malls are using our purchase history to analyze and predict our spending behavior. For example, if you're accessing to Facebook, our life now is in the Facebook, Twitter, so many social medias. So people are collecting all those data to populate, to study, to analyze. To analyze for what? To develop application to study on our behavior, buying behavior. So maybe it could be one of the marketing strategy to sell the products, to market the products to the people around the world. Okay, so that means by using a different data, okay, which we think it is not so important for last 10 or 20 years back. So, but now we look at, it's very important. It's a big data. You create data from another data. You populate and it becomes bigger and bigger and it's growing. So why not use it to discover, design and develop new drugs? Yeah, for example, now the pandemic with the COVID. So why we can't use this data science to discover, design and develop new drugs? Okay, for example, maybe we can look at this data science in drug discovery. Just example, okay, to make us understand, to make us better understand on this data science. Okay, and if you look at here, to discern structure, activity, relationship of chemical library. Okay, that means you design a drug. Okay, to formulate the drug. Okay, to develop a drug, okay, you need to have a chemical algorithms. Okay, you need to form with the formulas and so on. Okay, you form it, you design it. Okay, but in vitro data are limited. So for drug discovery, expensive, time consuming, laborious. Okay, so we need to think a lot of we need a lot of inputs. We need to done a lot of tests. We need to explore many things. Okay, so computational models. So you have these computational models where you can relate the biology. So I'm still in biology environment because I want to relate to the bioinformatics. So biology, and we merge with the computer science knowledge, IT knowledge. So we form a computational model for what can be quickly built to predict the pharmacokinetics, okay, and bioactivity of QB compounds. Okay, you form chemicals, okay, so that these computational models will help the chemists, help the scientists to produce, to make a QB, okay, to analyze, to predict, okay, on the drug discovery. So models can be used to repurpose existing FDA approved. What is this FDA? Okay, later I'll share with you. FDA approved drugs for new therapeutic treatment. Okay, therapeutic treatment. So that means any drug, okay, even anything that we research before we make it as a real thing, okay, we will have a model, right? For example, I think you know better about this. Models can be applied for developing personalized medicine. Maybe the model that I develop is suitable for myself. It is not suitable for another person. So that means you need to do a study, you need to research. Okay? So you need to put a lot of investment. It will take time. Okay? So that's how it will slowly will help us to discover a lot of new findings, new improvements for the drug discovery. And now we look at this QSAR modeling. What is this QSAR modeling? So quantitative structure activity relationship, QSAR modeling. Okay, it's a mathematical modeling that seeks to discern the relationship between the chemical structure and their bioactivity. So we will be using the mathematical knowledge here. So data science also part of the mathematics knowledge. So the chemical structure is defined by a set of molecular descriptors that can account for local or global physiochemical properties. Okay. Local features, the number, percents of specific functional moieties, molecular fingerprints. Okay, we can use the quantitative structure activity relationship we call QSAR. So as a global features, a molecular weight, lipophilicity. Okay, so these are the relationship modeling. So in a data science environment, you will not have only one area. You will have a multiple area where you will use to discover new findings, new outputs, new results. Okay, so data sets. So we relate to the data sets in the data science. A data set can be thought of as a data subset that you are interested in learning about. So if you can refer to here, I think you're familiar with the Excel, Microsoft Excel, for example, the columns and rows. So you will have two different variables here, variable X and Y. Okay. So a tabular data set is an N times N matrix. So the columns will be the features independent variable, input variables. You can put any value. Okay. Y is a dependent variable to X independent variable. So to find out the new Y, the new output of Y variable, you need to input a lot of new things. You need to study, you need to analyze the data to form the new Y. So that's why you can see here you have X1, X2, X3, X4, X5 with the different data. Finally, to come up with the result. To come up with the result that can give you a hypothesis. Okay. So this is exploratory data analysis we call EDA in data science. So EDA is performed in order to gain a preliminary understanding and allow us to get acquainted with the data set. Okay, there are three major EDA approaches. One is the descriptive statistics. Okay, just now I've mentioned in data science, you have a mathematical formulas. Okay, you have a mathematical field, you have statistical, programming, software engineering, machine learning. So statistics will be one of the approach. Okay, by using the statistics, we have three different approaches here. Descriptive statistics, where you will find the mean, median, mode, standard deviation, okay, in the data. So by getting this descriptive statistic, you can explore further to visualize the new ideas, new output from your research. And then you form it in the data visualization. Okay, you can see the data visualization. It can be in the heat maps example, box plot, scatter plots, PCA, for example. So you can form in a different ways of data visualization by study the, analyze the data. And then data shaping. Okay, pivoting group, filtering data, concatenate the data. So you can study the data, you analyze the data, you can do anything with the data. Okay. Finally, you will get new findings, new ideas, new approaches. So another way of analyze the data we call data splitting. So in a data set can be split into subsets in order to allow the evaluation. Okay, evaluation of the models. Okay, as I mentioned just now, in data science, you have models. You create a machine learning models, new models, extrapolation ability. So where you have the initial data, the raw data, initial data, you after you analyze, you do the analysis, you do the experiments, you split out the data splitting. Okay, it can be a training set or testing set. It can be 50% or 50%. It can be 70% or 30%. Okay, so you can evaluate those data to formulate the output. So this is the cross-validation. In data science, cross-validation makes the most economical use of the available data. Okay, so the data set is partitioned to n folds. Commonly, you can see here there are 5 folds or 10 folds. Okay, example cross-validation are used. So you can see the main data set. Okay, and then you have an example of 5-fold cross-validation. Why you do the cross-validation? By doing the cross-validation, maybe you can find a new output. Okay, you can use a training set. Okay, you can see fold 1, fold 2, fold 3, fold 4, and 5. You can see there are training set. 4 of the folds are training set, and 1 is the test set. So you will iterate. Okay, you will do many times. You will iterate until you get the findings. So not limit to the iteration 5. It can be more than 5, or it can be less than 5, until you discover the findings. So learning algorithms in data science, as I explained to you just now, you have 2 ways of learning. Okay, learning algorithm, supervised learning. Okay, in supervised learning, it's a machine learning task that establishes the mathematical relationship between input X and output Y variables. So that means you need to have these 2 variables as a supervised learning. Okay, you guide the variables. So such XY pair constitutes the label data that are used for model building in an effort to learn how to predict the output from the input. So this is what we call supervised learning. So that means we will input the X variables. Okay, Y always will be the dependent variable. By not having the X variable, you cannot find the variable Y. So it's effort to predict the output from the input. So you have a different output, you may have a different. You have a different input, you may have a different output. So that's why we have the supervised learning with 2 different variables. Unsupervised learning is a machine learning task that makes us of only the input X variables. Okay, so that means you only learn by having the X variables. Such X variables are unlabeled data that the learning algorithm uses in modeling the inherent structure of the data. That means we don't know whether the outcome of the unsupervised learning will be in any form, different form. Okay, so such X variables are unlabeled data. So that means you will not predict, you're not able to predict. Okay, so the outcome of the X variable by using this modeling for the inherent structure of the data. And then you have reinforcement learning. What is reinforcement learning? In reinforcement learning, it's a machine learning task that decides on the next course of action. And it does this by learning through trial and error in an effort to maximize the reward. Okay, in effort to find out the output. This is what we call reinforcement learning. You enforce. Okay, enforce. You ask the machine, you apply the algorithm, okay, that decides on the next course of action. So you ask the machine give you some suggestions, any other new findings, any other new algorithms that we can use to formulate, analyze the data. Okay, so types of machine learning tasks. Okay, so we already looked at this supervised, unsupervised learning and reinforcement learning. Now we look at the types of machine learning. So all this supervised, unsupervised, and reinforcement learning is actually help us to apply, to create model, to input into the machine learning to analyze. Okay, so there are two ways of common machine learning tasks for supervised learning. Okay, so now we talk about the supervised. Okay, where you have two different variables, independent and dependent variable x and y. So how you actually analyze? We can do the classification. Okay, one of the way of analyzing the data will be classification, and second one is regression. So what's classification? Classification, the trained classification model, okay, takes as input a set of variables, either quantitative or qualitative, and predicts the output class label we call qualitative. Okay, so you can see there is a class A, class B, class C. So you classify the group data. So by the following figure shows three classes as indicated by the different colors and labels. So each small colored sphere represent a data sample, whereby each sample, so you have a different sample, okay, but actually you populate from the same data. So this is what we call trained classification model using machine learning. And next is about the next task, okay, machine learning types of machine learning tasks will be regression. So a trained regression model can be best summarized by the following simple equation. Again, the mathematics comes here in data science. Okay, mathematics by using the dependent variable y. So you need to input the independent variable x. So the value will be, you have a different predictor value. Okay, so this is one example by using this function y equals to fx. So y can be calculated if x is known. So that means different variable x will give you a different predicted value. So this is the type of machine learning for regression. So what is in QSAR workflow? Just now I've explained to you the workflow, right? Okay, quantitative search relationship. Okay, it's a model. So a constructed QSAR model can be explained. So application of machine learning to drug discovery. So this is one example. Okay, so if you can see here, you have molecule 1, molecule 2. Okay, but molecule 1 will carry a different chemical here. Okay, molecule, atom, different atom. So here you have a green color, and then you have here you have a red color and green color. So this is molecules, molecular descriptors. Okay, you identify, okay, the descriptive of the molecule, each molecule, and then you form a data set. The data set by using the variables, different variables here. Okay, whether the variable or the molecule is active or inactive. Okay, by using the data set, okay, you form the model, you apply into machine learning model building. Okay, you create a new model. So by having this new model, so the molecule 1 and molecule 2 data set, you form a new molecule 3. So this is a new predicted value. So if you can see the result, okay, the output of the variable x, 8, 10, 5, 15, and 9, you will have a new features here. Okay, y variable x 8 and x10 will give you a different value compared to the other x variables. So you can study on that. So it will giving you a new findings. So this is what we call feature importance. By doing the prediction, the predicted value from the model that you created, okay, you will analyze, you will create the feature, a new feature. Okay. So next, we will look at the data science tools. So all this while we are looking at the data science overall about the idea. So what is data science? What are the process, workflow, okay, the algorithm learning, machine learning involved in data science. So the next important thing is here about the data science tools. What are your options here? Okay, so by using the data science tools, you can differentiate or classify the data science in 3 different options to create the machine learning in the data science. Okay, you can use no code. You create the output by using the graphical user interface based such as Vika, Orange, Nim. So these are the, you are not necessarily required to write a long programming coding. So maybe in 1 or 2 lines, okay. So we'll create the output. You can analyze the data, and you can see the low code. So that means just require minimum lines of programming coding. Auto ML such as Pi Carrot, Teapot. So these are the example of the data science tool where you need to create a coding for the machine learning to analyze the data, but without using 1 or 2 lines of programming coding. And with the code, maybe for this third option, you may need a very, very long programming, for example. Okay, but in the Python and R programming, you can create the programming for data science. So these are the future tools, some of the future tools in data science. Okay, you can create to solve your problem. So by analyzing the data. So these are the 3 options, data science tools for us to analyze the data. So finally, how can you learn data science? Okay, how you can learn data science. So if you can see here, the charts here, the art of learning data science. Okay, so you have the idea. What is data science? So first you start with the planning tips here, sharing with us that set learning goals, create your own personal curriculum, making a schedule, consistency, accountability. Okay, so these are the tips for us to learn data science. It's earlier stage, the beginning stage of learn data science. And then we move on to the learning phase. Learn just enough to start building. Okay, you must start somewhere. You need to start to learn. Okay, you apply Pandora, okay, to manage learning time. So it's an app, okay, to minimize start time, get stuck, move on and come back to it later. So that means you can use this example to start learning data science. Okay. So learning resources. What are the resources available? We have a lot of resources, not like 20 or 30 years before. Okay, nowadays with the YouTube, with the podcast, YouTube, Spotify, SoundCloud, so many books. That will be the last option. Reading books will be the last option always. So we always want to find out the information from the Google, from the internet, from so many medias, okay, social media information platform, do online learning platform. So these are the learning resources available, okay, in the environment of data science. Okay, so then after you plan and then you use the resources available to learn, you need to build. Okay, what to build? Work on work-related projects. Yeah, every day we have our own project, research project. It can be in any environment, not necessarily to be in data science. Okay, if you have your own project, okay, it can be any research project. So work on weekend projects, use public data sets. Okay, you always can refer to the public data sets. Okay, or compile your own data sets. Okay, You can use Kaggle, complete on Kaggle. So these are the example of data sets available for you to analyze the data, to find out, okay, to build, to create your own model for your project. And then the next part about explain, okay, explain to someone is very, very always, you need to make everyone to understand. So because the understanding level of each one of us will be different, including myself. So explain your model to others, teach others, okay, mentor others. You can write a blog post, build well documented, okay, repository, make YouTube videos, give talks, okay, at meetups, conferences, and podcasts, draw infographics. Finally, you need to draw infographics. Okay. So this is some of the information about the data science, okay, and bioinformatics. Maybe I will just relate bioinformatics only a small portion in data science, but bioinformatics is already part of the data science because it's a interrelation between the data science, computer science, IT environment with biology. You take any environment, okay, it can be in mathematical formulas, mathematical environment, software engineering, programming, okay, it can be a machine learning. So you come up with the idea of learning the data science. So far I've explained to you about the data science overall. I'm just sharing, maybe not everything, just a part of idea about data science. Okay, so that's all my presentation. But before I end the session, I have you have any other questions? But actually, I have another poll there. I've created poll question. Okay, so to discuss about the future trends. Okay, the future trends impacting on our data science. Okay, so the future trends, if you relate to the data science, to everyone, our business environment, any organization now, very working hard to invest on the artificial intelligence. Now we are moving forward to the Industrial Revolution 4.0, right? So everyone is like, in any environment, manufacturing, production, in any environment. So they actually invest on the artificial intelligence and machine learning. That will be the first priority in the future trends of data science. The second part is about Internet of Things, okay, IoT. So we need to spend on the application development to integrate with the devices, okay, through the available communication platform. Okay, so that will be another trend in the data science. And third one will be the edge computing. So that means third one will be the big data analytics. So as we are growing, as you are doing the research, the database is growing, right? So you're expanding the data. So how you want to analyze the data? Because if you, as a researcher, as a student, you will populate, you will create so many data, but you do not know how to analyze it, which is the right way of doing the analysis, which is the right method. Right? So you need to look at the big data analyticals method. Okay, so that will be the another trend in the data science. It's about big data analytics. Okay, that will be another important aspect, okay, for us to improve, okay, to perform better, okay, in our environment, research environment, for the development of our community, okay, for progress. And then the fourth one will be the edge computing, the resources storage. That is another problem. Those days we are keeping all the manual documents, manual data, but slowly now we are moving to the digital environment, digital data. So the storage will be another problem. edge computing. So how you want to integrate your computing platform environment with the storage resources. We need to plan on that. Okay, so that will be another trend also in the future data science. So how you want to expand, how you want to keep all the resources in digital platform. Okay, cloud storage will be the one of the example, but what are the next level, the next way of keeping our data? Okay, so that's all about the trends, future trends in data science. Okay, so that's all my sharing session, okay, with you all. So if you have any questions, or we can share our experience, okay, ideas on data science. Okay, thank you. So if you have any other question, you always can share with me here. Thank you.
Thank you, sir. Participants, if you want to raise any questions to the guest, you can come forward. Dear participants. So we have a question in the chat box which states
Yeah. So okay. What are the feature selection methods used to select the right variables? So the feature selection methods, it depends to the variable. It depends to your study, which environment. Okay. So the study, because in data science, you not only have one way of analyze the data. You can use multiple methods, different methods. Okay. So different methods to analyze the data. So if you look at the selection of methods, you need to look at the variables from where you populate the data. What is your objective, your research objective, your research questions, and it will direct you to fill up the gap of your research. So you will be choosing the right method. So it's basically go to your research objective and research questions. Any other questions? Yeah. What are the drawbacks of the linear model? Okay, drawbacks. Yeah, linear model only give you the result. The output will give you a very limited output. Okay, you cannot progress further on the linear model. That will be the one of the drawbacks. Linear model is just give you to solve the problem, to analyze the linear problem in one way. So you don't have any other comparison. You cannot compare with other model. Okay, other findings. You cannot relate the linear model with other research. Okay, so that will be one of the drawbacks of the linear model. So linear model, you are referring to which linear model? So if you refer to it's a mathematical environment, there is a different way of doing drawbacks. If it's in a chemistry environment, in biology environment, they have a various variety of models. Okay, so it depends on which environment. So in future, data science can give you a different view as what I shared with you. So it's involved a different field, right? So I'm just choosing bioinformatics as one of the field. But if you look at other fields, it can be a different way, different selection of models. Okay, that's all. I think how should you maintain a deployed model? Deployed model. Yeah. So how should you maintain a deployed model? So the deployed is once you design in the machine learning, right? For example, as I share with you in the same thing goes to the SDLC, System Development Life Cycle, as same goes to the data science life cycle. In data science life cycle, yeah. So in a deployed model, it depends on the environment. Okay, so in which environment the model, the study, the data science study is in which environment. Okay, how should maintain? You need to have the future enhancement. Okay, so you do any research, you cannot limit the research with your, there will be no limitation. You need to your research. You cannot say that I already find out the final outcome. It cannot be. So you will have a further research. You will have the outcome. Okay, so you can research again your research to find out new outcomes, new studies. Okay, you can use your research as a new case study, and you can form a different model. Okay, so progression. Okay. Any machine learning segmentation models? Machine learning segmentation models. Machine learning, as I told you that machine learning, you have supervised algorithms, supervised learning and unsupervised learning. So it depends on the different segmentation. Okay, different segmentation models in machine learning. So machine learning is not only about the algorithm. It's combination of artificial intelligence as well. Okay, you form a new technology, new ideas, you form a new machine learning. It depends on the model. It depends on the research problem. It depends on your research objective. As I always refer to the research objective and research questions. What you want to find out. Okay, so segmentation models. It can be a classification and regression. It's one of the example that I can share with you. Both segmentation and classification use same models. How it differs from each one? Of course, there is a difference. So classification, you categorize it, you group it. Okay, from the same data population, you categorize it by the characteristic of the data set. So some models, same models, it differs from each one. Yeah, of course. So by doing the analysis, you need to do the analysis, okay, by using a different method. So for medical image segmentation, how it suits? Yeah, data science, it's a part of medical, because in image processing, okay, you have the image processing, image analysis. So for medical image segmentation, how it suits, how IT suits or how it suits. Okay, I understand that how it suits. So yeah, data science not only limit to the biology, it actually expand to all other environment, all other areas. Okay, it go to the medical environment. So in medical itself, you have a different studies, right? Anatomy, okay, different levels, ideas of creating the knowledge. So we form the model by analyze. You implement, you invest your knowledge. Okay, you come up with that new algorithms. So same thing goes to the medical image segmentation. Okay, data science, future studies, you can actually integrate. You will form a new ideas, new outcomes. Okay. So latest research topic on deep learning. Latest research topic on deep learning. Deep learning is more specifically, you go in deep on the machine learning. It's a further exploration of the machine learning. Okay, deep learning, you are actually into the behavior, into the character, okay, of the problem. Okay, so it's deep learning. It's more to machine learning, but it's another way, another branch of, it's more to ideas on how you need to create the hypothesis from the research you've done. Okay, so it is possible in using linear regression for medical image segmentation. Yes, I can suggest, because the data is not, you cannot fix, okay, the linear regression for medical image segmentation in only one method, in one way. You cannot limit that. You can actually explore it. You can have a new ideas by using a different algorithm, machine learning. You can form another new linear regression. Okay, so it's based on image, how it's possible, because image actually you actually can convert it to the digital. You can digitize image in future technology. I think you can explore further and you can research and study on this. Actually, you can digitize the image processing. You can do the analysis. Okay, that is another we call learning. Okay, it's part of deep learning on image processing. Okay, deep image processing, deep learning on image processing will help us on the findings. Okay, on the process of develop the digitized method of images. Okay, you cannot limit everything. Nowadays, it's our world. The technology, every day you having a new technology, new algorithms. People are creating new ideas, so you cannot limit anything. You can further, but the only thing is we need to look at the ethical. Okay, it cannot harm our human. It cannot harm any animal. You know, of course, we use animals as a testing method, right? But you cannot create the artificial intelligence technology to harm any human being in the earth. As what you know, that's ethical issues or the ethical method. Yeah. Any other question?
Good morning, Professor.
Yeah. Thank you, ma'am.
Thank you for sharing your knowledge, sir. In the
Yeah.
QSAR model, in the place of molecular 1 and molecular 2, can we apply protein sequence?
Sorry, in molecule 1 and molecule 2, we can apply?
First, I want to know about in the molecular 1, what you are taken. In the molecular 2, what you are taken, sir.
Of course, it's a different variables, madam. So in molecule 1, because the data itself will come in a different, we can say character. It can bring a different value, right? Okay. Not necessarily molecule 1 and molecule. You cannot have the same two molecule to evaluate, to get the new idea. You cannot predict anything with the same model. Of course, it's a different molecular, okay, and it has a different character, okay, different idea, so that you can find out the prediction by using the machine learning. You can have a prediction.
Can be the same or different?
Different, of course, different.
Okay. Can we apply protein sequence in the place of molecular structures, sir?
Yes, can, madam. You can apply for the protein structure. So protein structure also, we have different, you know, different types of proteins, right? So you can actually differentiate for the proteins as well, different proteins. Yeah, welcome.
Thank you, sir. Thank you, participants. Thank you. It was really an interactive session for us, sir.
Yeah, it is also it's also knowledge sharing session. I thought that is as a knowledge sharing session.
We really had a knowledge sharing.
Yeah. Thank you so much, madam.
Thank you, sir. To end up the session formally, my request, Mrs. Arulmoli, show her gratitude to the guests. Ma'am, please.
Thank you, Shobana ma'am. The best and beautiful things in the world cannot be seen or even touched. They must be felt by heart. Thank you is one such prayer among them. I am Mrs. Arulmoli. Consider it a great privilege to propose a vote of thanks to today's session speaker Parthiban Varadaraju, lecturer and program coordinator, Faculty of Business and Management, MIST University, Malaysia, who have witnessed it as a memorable and successful event. At the outset, I thank our chief guest, Parthiban Varadaraju. We are really enlightened with your knowledge and presence. I once again thank to Parthiban Varadaraju for taking out time from their busy schedule and enlightening with this knowledge. Thank you so much, sir.
Thank you so much. Thank you, ma'am. Thank you, Mrs. Arul Molly. Thank you so much.
Thank you, sir. I would also like to thank our principal, Dr. A. Punaswamy, for giving support to organizing this session. I extend my gratitude to Dr. V. Saravanan, Professor and Head, Department of Information Technology, to organize this FDP even amidst the pandemic. I congratulate all the participants for their active participation. Thank you everyone once again for making it a great success. With these warm words and kind message, we move to the end of today's session. Thank you all.
Thank you.
Thank you,
very much,
sir.
ma'am.
Thank you.
It was a wonderful session and a wonderful knowledge sharing session. Thank you so much.
Maybe in the future we can have another session. So to
True, sir.
explore.
True, sir.
Yeah.
Yes.
Thank you so much.
So we can have in-depth sharing of knowledge and all
Sure,
our
sure.
doubts can be clarified.
Sure.
It was
Thank
very
you so much.
informative session, sir. Thank you so much.
Thank you, madam. Thank you so much, Madam Shobana, Mrs. Marrynal. Thank you so much.
Thank you, sir.
Thank you so much. And also, please send my best wishes. Thank you to Dr. Sudhakar.
Sure, sir.
Sure.
Thank you so much. Thank you so much for the opportunity.
Okay, so thank you so much.
Thank you.
Participants, we will close the session for today. Tomorrow being the last day, we request all of you to be on time. The session will start at 10:30. Thank you.